Good morning, Year 8. Today is the 6th of April, 2020. We're now going to move on to part 2 of Unit 2, Working with Powers. So 2.1, Simplifying Expressions, part 2. We're now going to do questions 8 to 11. So yesterday's lesson, we started looking at simplifying, collecting like terms. In today's lesson, we're going to look at simplifying and collecting like terms, but we need to first expand the brackets, and then we collect and simplify. So having a look at the worked example here, it says work out 4 within brackets x plus 5 plus 3 within brackets x minus 6. Now remember, in yesterday's lesson, we said that if you see brackets, first thing you should do is get rid of them, remove the brackets by either multiplying them out or expanding. It means the same thing. So if we look at the example, so we've got 4 multiply x plus 5 plus 3 multiply x minus 6. So if we do the first one, so it says expand the brackets, so we're going to do 4 times x, which is 4x. 4 times a positive 5 is positive 20. Then on the right hand side, you've got 3 times x, which is 3x. 3 multiply a negative 6. Remember, positive times a negative is a negative, so that's going to be negative 18. Then collect, simplify, bring together the same creatures. So 4x plus the 3x, 4x plus the 3x is 7x. The positive 20 take away 18. Remember, this is a negative 18, gives you a positive 2. So if we now look at the if we look at the second example, you've got 6 in brackets p plus 2. Then on the right hand side, you've got negative 2, then in brackets p plus 1. So again, remember, everything inside the bracket is multiplied with what's outside the bracket. So we're going to do 6 times p. 6 times p is 6p. 6 times 2 is a positive 12. On the right hand side, we've got negative 2 times p is a negative 2p. Negative 2 times 1, remember, negative times a positive is a negative, so that's going to be negative 2. Then collect and simplify like terms. So 6p here, take away 2p is 4p, so that's the same as saying, like, what is 6 take away 2? That's a positive 4. And then a positive 12. So again, I'll do this in a slightly different color. So positive 12, take away 2 is a positive 10. So again, what is 12? Take away 2, and the answer is a positive 10. So then that simplifies 4p plus 10. Okay. Alternatively, another way of working these questions out is using the grid method. So if we do 4 times x, which is 4x, 4 times 5, positive 20. Then on the right hand side, I'll do this in a different color. 3 times x is 3x. 3 times the negative 6 is a negative 18. So then write out the terms again. So we've got 4x plus 20. Then on this side, you've got 3x minus 18. So we bring this all together. So the 4x plus the 3x, as we saw previous, is 7x. The 20 minus the 18 is a positive 2. So again, it's the same thing, same result, 7x plus 2. Look back, 7x plus 2. But obviously, writing it out in this way in the grid and doing the multiplication as you normally do kind of makes it easier to work with. So we now have these questions. Question 8, which says expand and simplify. Now remember, you have to show your workings. So your workings can be shown like this, or you can do it like in the worked example method, your choice. I would suggest use the grid method as it makes it a little bit less messy, if you like. So I'll do the first one with you, then you guys try to do the rest. So we've got 3 and in brackets x plus 5. Then on the right hand side, we've got 4 multiply x minus 2. So again, 3 times the x is 3x. 3 times the 5 is a positive 15. Remember, this is a positive 3. There's no negative sign in front of it, so that tells us it's a positive 3. So positive times a positive is a positive 15. Then on the right-hand side, we've got 4 times x is 4x. 4 multiply times negative 2 is a negative 8. So again, write them out. So we've got 3x plus 15 plus 4x minus 8. So again, let's look at which creatures are the same. We've got 3x plus 4x, that's 7x. And the positive 15 take away 8 was 15 take away 8, well that's a positive 7. Let me just underline these again in different color. So positive 15 and the negative 8, 15 take away 8 is a positive 7. So this simplifies now to 7x plus 7. So remember, you've got to show your workings. So use either the grid method, like I've shown you here, do the multiplication, write out the terms here, then collect and simplify. You can show that you've come to the, you can't simplify any further by double underlining to show this is as far as it goes. So you guys now do the rest of question 8. So do B, C, D, E, and F. Remember to write them out clearly, show your workings, and show your final answer. Moving on to question 9, it says, write an expression for the area of the larger rectangle. So this is 2 rectangles here. You've got this rectangle and a smaller rectangle inside. Now remember, area is the length times the width. So let's say this is the width and this is the length. And it says, write an expression for the area of a larger rectangle. So you're basically saying, like we've done before, it's multiplication. We're saying 8 times x plus 3. Then it says, write an expression for the area of the smaller rectangle. So again, you've got the width here and the length there. I'll let you do that part yourself. This is part A. And then it says, write an expression for the shaded area. So what is the area of this part here, the green part? So remember, you would have done a question like this previously. So if you've got 2 shapes and you want to work out the shape, the compound shape with smaller shapes. So basically saying, okay, what is the area of the large green rectangle, subtract the area of the smaller white rectangle. That will give you the expression, the area of the shaded part. Moving on to question 10. So we've got these 2 signs. We've got this equals to sign, and then we've got this equal identity. So we have seen this before, the equals and the identity signs. So the equal and identity signs are not printed in the statements. Decide if each one is an equation or an identity. Now, with equations, they always have this equal sign, which shows that the 2 sides of an equation, say for example, x equals 10. So this is an equation where the 2 variables are connected with this equal sign. The identity, so as it says here, the key point equation has an equal sign. It is true for a particular value. So x equals 10 will only be true if indeed x equals 10 is a solution. So if I said to you 20 minus x equals 10, what is the value of x? You would say to me, well, x is 10. 20 take away 10 equals 10. So in this instance, x equals 10. But there could be other questions where it might say 30 minus x equals 10. So x would have now be a different value. So it's not true all the time. So it's an equation with an equal. So here's an equation because it's true, it's correct for this particular question. But in a different question like here, where it says 30 minus x equals 10, x has a different solution, a different value. So it's not true all the time. So as it says here in the example, 2x plus 5 equals 11 is only true for when x equals 3. 2 times 3 is 6 plus 5, 11. This will only be true with x equals 3 in this kind of question. The identity symbol, we've got 3 lines, is sort of the 2 lines, which we normally see, is that shows that 2 expressions are always equivalent. That means they'll always be the same. So example, x plus 5 will always be equal to 2x plus 5. Doesn't matter whichever question you see, this is an identity. It's not an equation. It's always equivalent, always true. So in these questions, it says the equal and the identity signs are not printed in the statements. Decide if each one is an equation or an identity. So you look at these questions, and then you can put in here either the equal sign or the identity sign to whether to say this is an equation or an identity. Have a go at them, see how you do. If you get stuck, message me and I can respond to you, or I can respond to you via Zoom. The next question, question 11, reasoning. So this is using your common sense. Show that 2x squared plus 2x squared is an identity. It's always true. It's 2 to the power of 3, 2 cubed. So is 2x squared plus 2x squared always the same as 2 to the power of 3? Part B, is x squared plus x squared always true for x cubed, true for all values of x? So that's basically saying if I got x squared plus x squared, will it always be equivalent to x to the power of 3 by using different values for x? So if I say 1 squared plus 1 squared, will it always equal, for example, 1 to the power of 3, choosing different values? Try some values, see what happens. You can use a calculator. So is it true for all values of x, or will it be different for if I choose, if I use another number? Say, for example, if I chose to use number 2, so it's 2 squared plus 2 squared, always equivalent to 2 to the power of 3. You can have a go at this question, see how you get on with it, try something. But as always, if you get stuck, message me and I can respond to you either by message or email or direct Zoom. Okay, so that's all the questions we're doing today. Try your best. Remember to show your workings. Pick one method that you like, and then we'll continue with this lesson on the next day. Thank you, and stay safe, and remember to wash your hands.